We learn about Gaussian elimination. Okay. Before we learn about Gaussian elimination, I'm going to show you a couple forms. One's called low echelon form, one's called, I covered up. This is 1.2. 1.2. So let me go to 1.2 first. Okay. Okay. Because this book is not only used by me, okay? What happened was that when Dr. Yao taught it one time, he didn't have a book, so I loaned him the book. So it's a little bit messy. Okay, we're going to learn called a couple formats for when we're using Gaussian elimination. Okay, we learn two formats here. So before we learn the format, I'm going to show you just a 2x2 matrix first. 2x2. Now when they said 2x2, they means a row. This is a row here. The first number always represents a row, okay? The second number always represents a column. Okay. And then 2x2 means a 2 rows times a 2 columns. You guys follow me here? So this means a by, sorry, not 2 times. Means a 2x2, okay? Means a this matrix made up by 2 rows, 2 columns, okay? So let's say it's A, B, C, D. Okay, here's a 2x2 matrix here. Your goal is to make it to be 1 or this is 2, okay? Depends on what they want to use. The first thing to make it to be is called a low echelon form. Okay. The second is called reduced low echelon form. So what's the low echelon form? Low echelon form looks like this. You get a number, and then 0 and number. Okay? Just any number here, any number, okay? And then, but you get a 0 under the first number for 2x2. And the number, they looks like a lower triangle, so it's kind of like this. So a low echelon form is you're going to create a lower 0 triangle, so it's like this. So if you're going to 3x3, they're going to be like that too, okay? You can draw a little triangle here, okay? And this is any number, okay? Any number. That's a low echelon form. And then the second one is called a reduced low echelon form. Now this one's a little bit more, strict, okay? This one has to have a diagonally, this is called a main diagonal. The main diagonal is right here, okay? The main diagonal is coming down like that. It has to be 1, okay? And then the main diagonal has to be 1, okay? And then this number, just any number. This one's a 0. So there are 2 requirements. The requirement, oh, sorry, not any number. This one has to be 0 also. Reduce the low echelon form is except the main diagonal is a 1, okay? Rest has to be 0. Yeah. Except the main diagonal is a 1, the rest has to be 0. And this is called reduced low echelon form, so it has a reduced sign. Now, which one's useful? This one, it can immediately give you the solution. This one will immediately give you a solution, okay? This one requires called the best substitution to get a solution now. So this one requires best substitution. Best substitution means you're going backward, okay, for solution, okay. This one you immediately get solution. So you said which one, most of people prefer this one because they kind of like give you a solution right away. But this one, very easy to make mistake, okay? And this one's less chance to make a mistake because you only need to create a lower 0 triangle And this one also has to create an upper zero triangle, okay? So there's a more chance you could make a mistake. So you always create a lower zero triangle first and then go to upper zero triangle. That's a little bit easier that way. You want to have a system. You want to have a system when you do this Gaussian elimination, okay? Now, the next thing is, I'm going to give you a couple examples. Oh, one more thing. Note, this is a note. Okay. The note is that if you have a zero in the whole row, that row has to be in the bottom. Okay. A row with all zero need to be in the bottom. Okay. Needs to be at the bottom. Okay, so if your rows are only zero only, then you got to put it in the bottom. Okay. Now here's an example for, so you row echelon form first. Okay, examples. These class examples. So when I just say example, means that this example is not from your book. Okay. Let's say I have 5, 1, negative 4, 0, 9, 2, 0, 2, negative 3, 6, 7, 31, 0, 0, 0, negative 2, 4, 9. Okay? Okay, this is called the low echelon form. First of all, let's see. Do I have a lower zero triangle right here? Is that right? Right here. Okay. And a number, this is a number, okay, a 5 on the top. Any number. For the low echelon form, that can be any number. Okay, and I think that's all you need to do. And then this number we call a pivot number. What's a pivot number? Pivot number is a number you use to zero out the rest of column entries. A pivot number is a number used to zero out the rest of entry in the same column. Okay, that is called pivot. So sometimes you hear, if you go to look at the YouTube, sometimes people say, "Where's your pivot number? Where's the pivot number?" They miss that number. Okay. This number we use to zero out these 2. Is that right? Make these 2 to be 0. That makes sense? Okay. Now, do you see any other pivot? You can only have one pivot, one column, and one row. Okay. One pivot in one column and one row. So if this number is a pivot in this row, you cannot have any more pivot here. You guys follow me here? If this number is a pivot in this column, you cannot add another pivot. That makes sense to you guys? You can only have one pivot in one row, one column. Okay. Now, can you guys see any other pivot in this matrix? Any more? Negative 2 here. Why? The negative 2 made it to be 0? No. So if you have pivot, you have to make the whole rest of the number to be 0. Okay. Can this be a pivot? No. Why not? Because the 2 took the pivot already. You cannot have 2 leader in the same group. Okay. You cannot have 2 pivot in the same row or same column. Okay. Because pivot made this to be 0.
Oh.
So they made all the entry underneath to be 0 or above to be 0 also. It could make above to be 0, okay? When we do this one. When we do this one, you can have your pivot, if this is a pivot for here, it can be for here also, but this is a low echelon form, so I don't need to make this to be 0. That makes sense? I just need to make this to be 0. For the low echelon form, you just need to make a lower 0 triangle, okay? Some people call the upper triangle, or you can call the lower 0 triangle. You guys follow me here? You say upper triangle, that means this is a number not 0, okay? But when you say lower 0 triangle, that means that this number is all the triangle in the lower triangles all 0, okay? Any question here? So that's the first example. And let's see another one. This one for reduce. Reduce a low echelon form. Okay. 1 negative 3 0 1 negative 3 0 0 negative 7, I think only 1 0 0 1 0 2 13 0 0 0 1 5 negative 9. Okay, you look at this number. What time is it? I don't.
9:13.
9:15.
9:13.
9:13.
Yeah.
Okay, so can you show me all the pivot here? Like this is reduced low echelon form. Reduced low echelon form means that you're gonna have a what? You're gonna have a, once you get the pivot, the rest will be 0. That right? Okay, not just the lower 0, but upper also. So how many pivots do you see? 1, no, not like the 3. 1 ticket, right? One of the most pivot points will come down the stairs. Okay, pivot point come down the stairs. So 1 and then what? This one don't take it, so this one cannot be this one. Okay, right? Any more? This one. So 3 pivot. Okay. Now let's do some example from your book. Oh, one more thing. If you have low echelon form, can you be a reduced low echelon form? If you are here, will you be this one also? Or if you're this one, will you be this one? Well, here's what happened, okay? If you are reduced low echelon form, you're definitely is a low echelon form, okay? So here's the, if you're reduced, okay, you are also going to be low echelon form. Okay, and if you are low echelon form, this is main log. Okay. Oh, there's one more thing I forgot to mention. Actually, this number is also pivot because each row got a 1 pivot. I forgot to mention that each row have 1 pivot, so that means that this one can also be pivot. Because every row have, it's just that you don't see the bottom here. Okay, this one can make this 2 to be 0. Okay, this one can make this 2 to be 0. I just didn't make it. It can. So pivot means number 1C. They ask you, the question is, they said, determine whether the matrix is in a row echelon form, reduced row echelon form, or both, or neither. Number 1C. Number 1C. What kind of format is this one? Okay. Do you see pivot for do you see pivot for first one? First row. It's about 1, that right? Okay. Second row, 1 also, right? And the last rows are all 0, so all 0 go to the last row. So this is a reduced row echelon form or row echelon form? Reduced. So both, is that right? Yes. And the second problem is E. E. Right here. Number 1E, sorry, number 1E. Right, this one. This one's both. I put down both. How comes both? You have pivot right here, right? 1, right? Okay, 1 is a pivot, and then for the first column, first row, right? And then there's a 0. 1 is already a pivot, so 2 cannot be a pivot. Okay, so that's why 2 doesn't. I didn't circle 2. And then this 1 is what? Pivot, because this 1 can make the rest of the row to be 0. That right? That's the column to be 0. Okay. Number 3 cannot be because you took 1 already, so you cannot even look at that. You stare down. You have to come down like a stair. Pivot points always come down like a stairs. Okay. So the last pivot is what? This one. That right? This one can make the rest to be 0. Okay. Now this is in a reduce echelon or just a row echelon or both. Both, because you can see that the pivot, anything with the pivot, the rest of what? 0. That right? So pivot for reduced row echelon form, everything's a 1. The pivot is a 1. The rest should be 0. Okay. Let's do number 2. Number 2, we're going to do A. What kind of form this one? This is a row echelon form because of what? The 2 is not being 0, that right? Did you see it? Now once the pivot here, that right? The pivot is 1, and then but you have these numbers are not 0. It's a 2, is that right? So therefore it's a row echelon form. And let's see E. Okay. E, I put leader. How comes a leader? Can you tell me? What's wrong with this format? You cannot have this format. Why not? What's wrong with it? The zero should be in the bottom, right? So they did not put in the right format, so it's a no. Okay. And so that's basically. Now the method we're going to use is called a Gaussian Jordan and Gaussian elimination to solve. Okay. So Gaussian Jordan is using the reduced row echelon form. Okay. So this one, I'm going to put down right here. Like this one, the solution you use by Gaussian Jordan, okay? By Gaussian Jordan, and this one is just by Gaussian. By Gaussian elimination. So 2 methods. If they say using Gaussian Jordan, they're talking about reduced row echelon form. If they said by Gaussian, they're talking about use best substitution. Okay. So let's do one problem, then we're done for today, and that will be problem number 6. Number 6, they say. Okay, let's look at number 6, what they said, okay? They said, solve the system equation by Gaussian elimination. So that means what? low echelon form. Okay, you need to produce a low echelon form. So now this is the top part. I remember I have one of these student. He was really confused about which way to how to start it. So I'm going to teach you. Okay, then you have the system in your head. Okay. So number 6. 2x1. So I'm not going to write it because that takes me a little time. So you have the book you guys look at. So first of all, write down your augmenting matrix first. Okay. So 2, -2, and then 8, and then 2, 5, 1. Okay. 2, 2, 4. And then you put, now this is augmenting matrix, okay, then 0, 1, -1. Now when you do this, make sure you do not make any mistake on your entry, okay? You make one mistake, then the whole thing will be off, okay? Make sure every number, you check it, every number is the right number, okay? So the first thing you should do, roll number, the first step is, what time is it?
9:22.
So this is closer to 9:25, huh?
We have 3 minutes.
Okay, you have 3 minutes. Okay, sorry about that. So the first thing you should do is try to make it to be 1. That's the number 1 step, okay? Make it to be 1 first, and then make the parallel number to be 1, okay? And then make the rest to be 0. Okay, that's the faster way to do the problem. So I'm going to take row 1 times by 1/2. You cannot divide row 1 by 2. You cannot do that, okay? That is not the way they operate by matrix, okay? I mentioned row operation is that you can only multiply. So you instead divide by 2, you multiply by 1/2, okay? So make it to be 1, 1, 1, 0, okay? And you keep the rest of it, okay? You just make it to be 1, so the rest of it don't change. Okay, and then row 1, you can operate at the same time. If you're using the same pivot point to operate on 2 different rows, you can do that, okay? So then say row 1 times by -8 add to row 3. You guys follow me here? So because the time, so sorry about that, then I have to you know what? Don't have time to do. I don't have time to finish the problem, so I probably just finish it next time. Okay. So right, it's only 9:24 now, right? Okay. So I just stop right here. The next time we're gonna finish. Okay. So I'm gonna call row first, and then